Hi everyone, my name is François Goudenov. I'm the Chief Sales Officer for Syntony, a company based in Toulouse, in France, and I'm here to talk to you about GPS extension in a tunnel environment to better protect people and save life. Syntony comes from the space industry and from the aeronautical industry, and we have developed an expertise in GPS solutions. I should say GNSS solutions, not only GPS, but it can cover also Galileo, GLONASS, Beidou, QZSS, whatever kind of constellation. And we are providing solutions for simulating GNSS or solutions for GNSS receivers. And because of this expertise, we started some years ago to work with the Stockholm Metro in order to provide GPS coverage. That was their request on an efficient way and a cost-effective way in order for them to secure the full transportation system of Stockholm. So that's how it started, and I will spend some time about this, and then I will go back to the rest of the presentation. So Stockholm operator wanted to ensure safety, security, and this is an objective they have to improve the security that is perceived by the passengers and to lower the cost as well from any graffiti, vandalism, and everything. And they have to interface themselves with safety forces, security forces from the police, from the firemen, from everyone. So for that, they have developed huge security centers, and they have a lot of camera everywhere, a lot of systems that are reporting information, and they are making real-time information collection, real-time decision, and real-time resource allocation. And that's where GPS comes in, because you need to know where your GPS, you need to know by GPS where the people are. From the Tetra system, you get that information, and based on that, you can reallocate the people in the full transportation system. Stockholm operator is not only operating the metro, they are operating the bus as well and everything. So their system is already working, and it works pretty well. And it works pretty well outside because GPS position is available from anywhere in the city. But it has to work also inside. And that information comes from all the users of the transportation system. So GPS position was a key parameter for that security center, even for underground operations. And that's where we come in. We are not talking about standard, let's say, indoor location system. We are really talking about providing GPS underground, and so that any kind of applications which have been thought to be working with GPS, they can work with GPS also inside the metro environment. Just let's think about the emergency calls, the 911 in the United States, E112 in Europe, emergency call from whatever kind. Your phone has to send a GPS position to the call center, and it can work if you have the GPS position. If not, it will address a position, it will send a position, which is the last position computed by the smartphone. It takes into account any other parameters, but it is not as precise as a GPS position. And sometimes you need that level of precision to save life. You need to know where it comes from, the exact platform it comes from, rather than just knowing that it comes from that big area. Another kind of use is also to help the people when they have to interfere with a very smoky environment, like firemen in some cases. If someone is falling in the street and you don't see them because of the smoke, at least you can catch them because there is a GPS position reporting available in the system, so you know where you have to go. It has also to work in a tunnel, because smoky situation and fire situation in a tunnel, and you know that better than I, are a real issue. And saving life goes through those typical applications, which have not been developed for working with our system. They have been developed for working with GPS. But GPS undergoes also to think about new kind of applications which were not necessarily thought before. For example, anti-collision system, alerting system that will tell all the workers that there is a collision risk, for example, between a train that's coming and some workers which are working along the track. There are many ways to avoid that kind of situation, but if it happens, at least you can have an alerting system in real time that will work based on the two different GPS position from the train and from the workers, and anyone will be informed there is a danger, and they will be in a capacity to act and react. Some other solutions can also be developed to help securing a location when the people do not respond. If someone is not moving anymore, I mean, there is a problem, and you have to find out where that guy is, and you have to save them because there is a problem. So thanks to GPS reporting, it's very easy to implement that kind of software and of applications. And it can also have a consequence in terms of economy. When you have to evacuate a road tunnel before to open it again to the circulation and to the traffic, it may take a long time for the operator to go inside the tunnel and make sure that no one is left. But if anyone is located with GPS, and you know where the people have left, in some other environment, it can be also very important in terms of money involved, like a mining environment, for example, and with ventilation and demand systems. Some mines tunnels are only ventilated when people are inside. So it's very important to know if some people are still inside the tunnel, if you want to manage this kind of systems. So GPS will allow a new kind of operations, and not only what's going on outside can work, but you may develop specific applications. You may think about new applications. You may think about using IoT, for example, located system, thanks to GPS position that is now provided, and which will help improving the safety, the security at some time. So that's exactly what we are doing. But for that, you need to get, and our system, Subwave, will generate GPS in underground areas. We think GPS as a commodity. Everyone is using it as a commodity outside. I mean, you don't ask for the permission to look at the satellites and to get the signals. You get them. And you have developed your environment to use those systems because the specification is available for anyone. So the same way we have thought that we could provide GPS inside underground environment, and that's basically what our system does. It provides the GPS RF signals inside the confined environment. So your smartphone, your GPS receiver will compute its position based on the signals that it receives. And our system is a computer which can generate in parallel different simulations, and the simulations are connected inside the mine to a broadcasting system, to an antenna system, should I say, so that you can receive those signals inside the environment. It has been already used in different metro, and it has been selected, for example, in New York City Metro. It is running in as I said, in Stockholm. It has been tested in many different environments, road tunnels as well. And the key characteristics are and really the signature, I should say, of the system is that we are emulating the exact GPS signals. It is therefore fully compatible with any GPS-based operation, and in particular, any TETRA-based operation, PMR-based operations, professional-based operation that works with GPS will be working from day one without any specific issue to perform by using our system. Location can be very precise, and we have measured with smartphones a location up to, or down to, should I say, 2 meters. We can be even more precise with very specific chips or very specific GPS operation that will work. It will provide also a seamless transition between outside and inside when using GPS, which is a key and very important factor. And since we are working with X, Y, Z coordinates, there is a capacity to identify the level at which you are performing. So your mapping system can be very precise and can identify what is the level of operations. And last but not least, the beauty of the system is that it is using the existing telecommunication infrastructure to broadcast the signals. So the implementation cost is limited in the sense that we do not have to develop a specific infrastructure. You can use the existing one. In a metro, what we'll do is we provide our transmitters. They will be in the same location, more or less, than the existing TETRA station and repeaters. And in the same technical rooms, and they will be connected to the same cables. Most of the time, the telecommunication infrastructure is based on leaky feeder, leaky cable, or radiating cable, should I say. Then if we connect our system to those leaky, we will be able to distribute the radio signal all along the tunnel and in the various stations if we want. It can also work with antennas, but it has really been designed and fit for leaky cables. So the capacity is the capacity of the leaky. I mean, if the leaky is 600 meter long, our system can cover a 600 meter long zone. We have 2 levels of system, or precision, should I say, what we call the zone-based location. As I say, we are simulating the GPS. You can see it on the left, and it will be connected to the leaky cable. So the leaky is connected through the RF output of our system, and then the simulation, the signals which are simulated, will be broadcasted all along the leaky. Every receiver in the vicinity will receive the signals and will be in a position to compute a position. They will all receive the same signal, so they will all compute the same position. But that's the way it works, and that's already very, very important. That's what is implemented in Stockholm, for example. They have enough information to know where they have to allocate the teams in real time because of the system. If we want to ensure there is a seamless transition between the outside world and the inside world, so somehow we need to connect ourselves and to synchronize ourselves with the GPS through constellation. And we'll do this by connecting an outside antenna, if it's possible, or we will connect through PTP server time synchronization mechanisms, which are most of the case already available in a tunnel environment for the radio and for the telecom. But if we want more precision to another kind of implementation, what we call continuous, subwave continuous, which gives you a precise location, we will connect different signals on each side of the leaky. So instead of having one unique source of signals, we'll have two sources, one on the left, one on the right, and depending on where you stand inside along the cable, the time of arrival from the signals coming from the left and the time of arrival from the signals coming from the right will be different. And because of that difference, the position that your smartphone, that your receiver will compute will be different as well. And this is how we can have a position which is different depending on where you stand on the leaky. And the level of accuracy, the level of precision that we get at the end of the day is very, very similar to the one that you have in the outside world. Outside, if you are in the city or if you are in the plane campaign, the precisions might be different, and depending on atmospheric phenomenon, you may have also some difference in positions. When you are inside the tunnel, it is not for the same reason. It doesn't come from the atmosphere, but you may have some differences which are linked to the geometry of the implementation. But the order of magnitude of the errors is very, very comparable. So that was a brief description of what does the system. I want to repeat it. We can help saving life. We can help protect people by using GPS as it is done outside. We can do it inside a tunnel environment. And that's exactly the essence of our system, which is to provide the existing GPS safety, GPS comfort, GPS existing services can be really implemented when using Subwave. So we believe this is a very important system for improving safety in tunnel environment, for the safety of the users, for the safety of the workers, for improving the security in terms of police operations. And we would be very happy to discuss it a little bit more and answer your question, should you have any questions. So please don't hesitate to contact us. See my face somewhere, yes, and my name. That's and most important of it, the contact, mail contact to come back to us. Thanks a lot for your time, and I hope it was clear enough, and hope to see you very soon and to discuss with you. Bye. Thanks a lot.